Section 4.5 is the L'Hopital's rule, which is a rule to calculate the limit of a function. This is the rule which says that if f and g are differentiable functions, and if g prime not equal to 0, and that's the main thing here now, if limit of f divide g is equal to 0 by 0 or infinity by infinity, then we can calculate the limit of f divide g by differentiating the numerator and denominator. Now there are two things to keep in mind about this rule. The first thing, this rule is used to calculate limit of a rational function. We have a ratio, and the ratio must be by substitution equal to 0 by 0 or infinity by infinity. Then only you can start differentiating numerator and denominator separately. For example, now here to calculate the limit of this function, we have a ratio, and by substitution this ratio is minus 5 squared. We are substituting minus 5, which is 25, minus 25, which divide by minus 5, plus 5, which is equal to 0 divide 0. So we have 0 by 0. We can start applying the rule and say this limit is equal to derivative of numerator divide derivative of denominator. If you start substituting now, you get the final answer, which is minus 10. You see, this limit could have been done using factorization, which is x minus 5, x plus 5, and so on. So here L'Hopital's rule here, it's applied for a very simple example, but the L'Hopital's rule is a very powerful method, and we are going to use it later on for limit of a function which cannot be really calculated using factorization. It is very important to keep in mind that this rule can be used only if the ratio is equal to 0 by 0. For example, if you try to use it for something like this, for example, let us say this is divide 2x when x approaches 2. By substitution, this is equal to 2 times 2, which is 4 plus 5, 9, divide by 4, which that's the correct answer. If you apply L'Hopital rule, you don't get the same thing. Derivative is this, derivative of denominator is 2, so when x approaches 2, this is equal to 1, which is the wrong answer. You can take any function here where the answer is not 0 by 0. If the answer is not 0 by 0, the L'Hopital rule will not give you the correct answer. So it's very important to apply the rule if you have a ratio, and the ratio by substitution gives 0 by 0 or infinity by infinity. Now, this is another exercise, number 12. Like we said, here find the limit of this function. Now, like we said before, to apply L'Hopital's rule, or to start applying L'Hopital's rule, we need a ratio, and the ratio should give a 0 by 0 or infinity by substitution. If you start substitution here, this is infinity squared plus infinity, which is equal to minus infinity divided by infinity. So we have a ratio. We can start applying the rule, L'Hopital's rule. Now differentiate numerator and denominator separately when x approaches infinity. If you start applying the rule, if you start substituting, this is minus infinity divide infinity, which means you can continue applying the rule. So this is equal limit. Now that means that L'Hopital's rule can be used repeatedly as long as we have a 0 by 0 or infinity by infinity in the substitution. But of course, if you continue applying more than 4 times, for example, if it goes too long, then there must be something wrong in the middle. Maybe you have to do some simplification. Now, if I continue here, it is getting more simple than before. I mean, this is more simplified now, which is minus 16 divided 24. This is minus 2 over 3. So we have reached the solution. This is your final answer, which can be seen actually here, because we have said in calculus 1, when x goes to infinity, we look at the powers. When they are equal, the answer is the coefficient of leading is the ratio of the leading coefficients. So it is actually minus 8 divided by 12. So the answer can be seen from the beginning. Minus 8 divided 12 is minus 2 over 3. This is what we got here. Another example is this. Limit of ln x divided cosecant x when x approaches 0 on the right. Here, 0 on the right is a requirement here because ln x is defined only for positive numbers. If you look at the graph of ln x, this is ln x. Ln infinity is infinity and ln 0 is minus infinity. So anyway, to apply the rule, we have a ratio here. This is what we need. And the ratio by substitution, it is ln 0 divide cosecant 0, which is minus infinity divided by infinity. So we have an infinity by infinity. So the limit, which is this, is equal to, using L'Hopital's rule now. Using L'Hopital's rule, this is equal to, I will differentiate numerator, which is 1 divided x, differentiate denominator, which is minus cosecant x, cotan x approaches 0 on the right. This is equal, by substitution again now, infinity divide minus infinity, which means we can continue applying the rule. But there's one thing you need to observe here, which is if you continue differentiating numerator and denominator, it will be always here 1 divide something with x, like for example the next derivative will be minus 1 divide x squared for this. So you will continue having 1 divide x squared or x cubed, and here you will continue having cosecant and cotan because derivative of cosecant is cosecant cotan and derivative of cotan is cosecant squared. So infinity divide infinity, it will be there, it will remain there, it will never, you will never reach an answer, which means that you must do a simplification before you continue. And the simplification here is very clear because you just have to take cosecant cotan to the numerator as sine and tan, and 1 over x is written in the denominator as x. By substitution, this is 0 by 0, which means you can continue applying the rule now. And it will be even easier to use the rule. This is 0 on the right. Now differentiate numerator, which is minus derivative of sine is cosine tan x, plus sine derivative of tan is secant square x, divide by 1. If you substitute, this is 1 times 0 plus 0 times 1 divide by 1, which is equal to 0. This is your final answer. Now we have said in the previous page that L'Hopital's rule can be used for the indeterminate forms 0 by 0 and infinity by infinity. However, they can also be used for these forms, 5 forms. All of these forms are indeterminate forms also because when they are written as a ratio or as a rational function, they will be 0 by 0 or infinity by infinity. So all of these are, like I said, indeterminate forms. They have no exact value, and when they are written as a ratio, they will be 0 by 0 and infinity by infinity, and so we can use L'Hopital's rule with them. For example, 0 times infinity, when it's written as a ratio, you can bring the infinity down as 1 over infinity, so it's going to be 0 divide 0. This is true for all of them. When they are written as a ratio, they will be either a 0 by 0 or infinity by infinity. So in the following exercises, we are going to take one by one and see how they can be written as a ratio and how can we use L'Hopital's rule with them. Now, this is going to be the first of these forms, the first of others indeterminate forms, which is 0 times infinity. We are going to see how to use L'Hopital's rule with this form. Like I said, or like I wrote here, I wrote that to handle this kind of indeterminate form, we're going to use algebra to change it into a fraction, which is a 0 by 0 or infinity by infinity, and then use L'Hopital's rule. We are going to do for all of them actually. For all of these, we are going to use algebra, some algebraic simplification to write them as a ratio and then use L'Hopital's rule with them. So let us see this example. Limit of x ln x to the power 0. By substitution, this is equal to 0 times ln 0 square, which is 0 times minus infinity square, which is equal to 0 times infinity. Now, to use L'Hopital's rule, we are going to start by writing it as a ratio. We can bring either x to denominator or this denominator. It will be easy to write, bring x, this x to denominator as 1 divide x. Now, let's make sure this is a 0 by 0 or infinity by infinity. By substitution, this is ln 0 square, and this is 1 divide 0, which is minus infinity square, divide infinity. This is equal to infinity by infinity, which means we can apply L'Hopital's rule now. So this is equal to, using the L'Hopital's rule now, the limit of derivative of the bracket square is 2, the bracket, derivative of what is inside the bracket, divide by minus 1 divide x square when x approaches 0 from the right. Before we start substituting, it is important that we simplify. This can be simplified. We can cancel this with this. So we are going to have 2 ln x divided by minus 1 divide x, which is where x approaches 0. By substitution, this is 2 ln 0 divide minus 1 over 0, which is equal to minus infinity divide minus infinity, which means we can use again L'Hopital's rule. Differentiate numerator, which is 1 over x. Differentiate denominator, which is a plus 1 divide x square when x approaches 0 from the right. This has to be simplified, obviously. So 2 times 1 over x times x square divide 1 when x approaches 0 from the right. This is equal to the limit of 2x, which is equal to 2 times 0, and it is equal to, let's write 0 here, 2 times 0, which is equal to 0. So this is your final answer. This is another indeterminate form, which is infinity minus infinity. It has no exact value. That's why it is indeterminate form, because infinity can be like this is small, it can be this big. So clearly infinity minus infinity is not a 0, it can be any answer. So here by substitution, this example, by substitution this is 1 divide 0 minus 1 divide 0, which is infinity minus infinity. To use L'Hopital's rule, like we said before, we must rewrite it as a ratio. This can be done as a ratio simply by combining the two fractions. So you have to multiply this by this and this and that. So 3x plus 1 times sine x minus x. Make sure in order to use, because we have a ratio, this is one requirement for L'Hopital rule. Second requirement, substitution should give a 0. This is 0 minus 0 divide 0, which is equal to 0 by 0. Which means we can apply L'Hopital's rule now. So differentiate numerator. Here you have a product. So derivative of 3x plus 1 is a 3 times sine x plus 3x plus 1 times cosine x minus 1 divided by derivative here also product rule. So sine x times 1 plus x times cosine x. And don't forget to write the limit here. This is x goes to 0 from the right. If you try substitution here, this is equal to 0 plus 1 times cosine 0, which is 1 minus 1. This is 0 plus 0 times 1. It's again 0 by 0, which means you have to apply the rule again. So you have to say limit of when x approaches 0 from the right. This is equal to 3 cosine x plus, this is a product rule. So you have to say 3 times cosine x plus 3x plus 1 times minus sine x, and derivative of 1 is 0. Divide by cosine x, and this is a product rule, so derivative of x is 1, and plus x derivative minus sine x. So hopefully we get an answer here. This is very long. If you try substitution, this is 3 times 1 plus a 3 times 1, and plus this is 0 plus 1, which is 1 times 0, divided by cosine 0 is 1, this is 1, plus cosine 0 again is 1, and this is 0. So the answer is 6 divided 2, which is equal to 3. One more exercise here, where by substitution this is equal to infinity minus infinity. You have to write this as a ratio, and the only way to write this as a ratio is by multiplying by conjugate. So x squared plus 1 plus x, divide x squared plus 1 plus x. X goes to infinity. Multiply, so you are going to have x squared plus 1 minus x squared. You multiply the root, and then this is x squared plus 1 plus x. X goes to infinity. So that's equal. We want, because we need a ratio. This is what we are trying to do now. We did not use the L'Hopital's rule yet. So this is x goes to infinity. Now we are going to reach an answer really without L'Hopital's rule, because this is infinity plus infinity, which is equal to 0. But in general, if we have a root with infinity minus infinity, in order to make it a ratio, we have to multiply by the conjugate. If the answer here is 0 by 0, you start applying the rule, but the answer here was not 0 by 0. We had an answer, which can always happen when you are simplifying a function and prepare it to use the L'Hopital's rule with it. Now these are the last type of indeterminate forms, which are 0 to the power 0, infinity power 0, and 1 power infinity. Now we are going to get these kind of answers and limit if we have a function to the power of a function. If we have a limit of a function to the power of a function, for example, if we have also x to the power sine x, this is a very famous example. This will give you by substitution a 0 to the power 0. Now, in order to write these forms as a ratio or as a rational function, which is equal to a 0 divide 0 or infinity divide infinity, we are going to use len. So whenever we have a function to the power, or whenever we have a limit of a function to the power of a function, we are going to use len in order to write it as a rational function, which will give a 0 by 0 or infinity by infinity. So let us see the first exercise. We have limit of x to the power of x. So since we have a function to the power of function, we are going to use len. How? By calling the given limit as y. And then take len of both sides. To simplify the idea, you can think about it this way. You can think about it as like we have put len here. So instead of doing limit of x to the power x, we are going to do limit of len x to the power x, because I'm going to concentrate now on this side. We're going to leave this until the end. The idea of taking len, because we can bring this in front of len using rules of logarithms. So we have a product which can be written as a ratio, because we need a ratio for L'Hopital's rule. So this is len x 1 over x. X goes to 0. Make sure this is a 0 by 0 or infinity by infinity in order to use L'Hopital's rule. This is len 0, 1 divide 0, which is minus infinity, divide infinity. Now, which means we can apply L'Hopital's rule. If you apply L'Hopital's rule now, differentiate numerator, which is 1 divide x. This is derivative of len x, and derivative of 1 over x is minus 1 divide x squared when x approaches 0 from the right. This is equal, simplify this, so it will be 1 divide x times minus x squared divide 1. So this is equal to This is equal to limit when x approaches 0 from the right for minus x, which is equal to 0. Now, this is 0 here now. This 0 is len y. You see, len y is equal to all of this. Now, we are not interested in len y. We are interested in y, which is the limit given to us. So if len y is equal to 0, then y, which is the limit required, this is the limit required, okay? So we have to say it's equal to e to the power 0, which is equal to 1. So we started by taking, if you think about it, we started by taking len, which is here, take len of the given function, and we have to end it with saying the answer is e. We have to reverse the operation. We took n, so we took e at the end. We have to take e at the end. One more exercise for these cases. When you have a function to the power of a function, again, like we said, we are going to call it y. 1 plus 1 divide x to the power of x when x approaches 0. And then take len of both sides. So len 1 plus x to the power of x. The idea of taking, now you think of this side now. It's like we have put, like I said, len here. So you work on the right hand side only. So you bring the x here. This is len 1 plus 1 divide x when x approaches 0. You need to write this as a ratio, as we said, to use L'Hopital's rule. So we are going to bring this x to denominator as 1 over x. We need to make sure before we start using L'Hopital's rule that this is a 0 by 0 or infinity by infinity. If you put 0 here, this is 1 over 0, you are going to get len infinity, which is infinity, and this is infinity. So we can start applying L'Hopital's rule. So this is equal to the limit of derivative of len is 1 divide 1 plus 1 over x, which is 1 divide u, times u prime, which is minus 1 divide x squared. This is derivative of this. Now, divide by derivative of 1 over x, which is minus 1 divide x squared, when x approaches 0 from the right. This is cancelled with this. So we have limit of 1 divide 1 plus 1 over x. If you try substitution, this is 1 divide 0, so this is 1 over infinity, which is equal to 0. Now again, 0 is len y. This is len y. Y is limit of 1 over plus 1 over x to the power s. Now we don't want len y, we want y. This is the question given to us. So final answer, you have say limit of 1 plus 1 over x to the power x when x approaches 0 on the right is equal e to the power, the answer here, which is equal to 1. So like I said, it's like, think about it this way, it's like you put len here at the beginning, start working. The reason we put len, so we can bring this power down and write it as a ratio. Here we wrote it as a ratio. Make sure the ratio is 0 by 0 or infinity by infinity. Apply L'Hopital's rule, and then at the end take e to the power of your answer. Now conclusion for L'Hopital's rule. It's good to keep the following points in mind. First of all, you can only use L'Hopital's rule if you have a limit of a ratio. So you must, if a limit is given to you, if the function is not in rational form, you must write it as a ratio. And the ratio also must be by substitution 0 by 0 or infinity by infinity before starting applying the rule. Second thing you have to keep in mind is when you start applying the rule, you differentiate numerator and denominator separately. You don't use quotient rule. One more thing which has to be kept in mind, that for all the different forms which we did, for example, we did all of these forms. We did 0 times infinity, infinity minus infinity. We also did 0 to the power 0. These are all the indeterminate forms which we have done. It is important to remember this is the basic one where you start using L'Hopital's rule. This one has to be written as a ratio in order to start L'Hopital's rule by simply bringing one of them to the denominator. This one has to be, the fractions they have to be combined in order to use L'Hopital's rule. Here, when you have a function to the power of a function, you are going to use len in order to write it as a ratio. Another thing which has to be kept in mind, if you repeat using L'Hopital's rule and it goes very long, like for example 4 times, then you have to stop and think about some simplification. Maybe you should have done some simplification in step 2 or step 3. So simplification is important when you are using L'Hopital's rule. So simplification, like I said, is important in between, or when you are repeating. Before you repeat applying L'Hopital's rule, you must simplify. Another thing which has to be kept in mind here, when we say infinity divide infinity here and in this point, or minus, it could be actually plus or minus. All the infinities can be plus or minus, so it does not matter. We don't have to, instead of 0 times infinity, for example, you can have 0 times minus infinity. So all the infinities here can be plus or minus. One final point which has to be kept in mind, if you have the limit of a product of a function, for example, when x goes to 0, this is 0 times minus infinity, so you have to write it as a ratio. It's very important to choose the correct one to bring to the denominator. You should bring the easy one. For example, here it's easy to bring the x to the denominator and makes it infinity divide infinity. Why? If you have something like cotan x times x when x approaches 0, this is now 0 times infinity, but it will not be so easy to bring x down. It will be easier to bring a cotan to the denominator as tan. So you see the reciprocals, which are cotan, secant, and cosecant, they are usually the one which can be brought to the denominator. Or if we have something like e to the power minus x times x when x approaches infinity. In this case, it will be easy to bring, instead of bringing the x, it will be much easier to bring the ex to the denominator and so on. So it's important to do the correct choice here. It will simplify the work more.